Hello, and welcome to Wrangling Data with dplyr functions. Now that we've had some fun plotting data, we need to learn how to wrangle or manipulate data. This video will introduce 6 functions, and in the next video, I will show you more details of the code in RStudio. This concept map lays out the 6 functions I will introduce and what they would be used for. The data I will use throughout this video in the examples is the rawest form of the garden data I collected. There is a row for each time I weighed a vegetable. So there could be multiple rows of the same vegetable on the same day, especially if there's different varieties. Even when there's not different varieties, there may be multiple measurements. For example, if I weighed lettuce at lunch and dinner, which was pretty common. These data, and most of the data we'll see this semester, are referred to as tidy data, meaning each variable has its own column, each observation its own row, and each value has its own cell. In R, the data sets are called data frames or tables. These have more specific meanings, which you will read about on your own. The pipe, this combination of symbols, %, arrow, %, gives us a way to connect sequential pieces of code, similar to the plus in ggplot. We read it as and then. It takes what is to the left of it and makes that the first argument of the function on the right. Since most of the functions we will use have the data set as the first argument, the pipe is then a way to take the data to the left of it, which may have already been manipulated in some way, and pass it along to the next step. We always press enter to create a new line after a pipe. This is for readability of the code. In the example here, the garden harvest data is then used in the ggplot function. We've seen this before. There are 6 main data manipulation functions or wrangling functions in the dplyr library, which is part of the tidyverbs suite. The function names are verbs in the English language that help communicate what they do. So I sometimes refer to these functions as verbs. Each verb takes an input data frame along with additional arguments specifying the action and returns a new data frame. Let's start with the verbs that change which variables or columns are included in the data frame, but preserve the same set of cases or rows. Select chooses which variables to keep, or put another way, deletes those variables that are not selected. To specify the variables, we can either list them out, or helper functions can be used to specify the titles of the variables we wish to keep. I'll talk about helper functions in the next video. In the code shown here, we start with the garden harvest data and then select the variables vegetable and weight. So only those 2 variables are in the resulting data set. Mutate adds 1 or more variables to the data frame. These new variables can be functions of other variables and can compare variables. The functions are applied to each case in the data. You can create more than 1 variable by separating them by commas. The name of the new variable is to the left of the equal sign. In this code, we compute 2 new variables. The first, weight LBS, converts the weight from grams to pounds. The second, over 1 pound, returns a true if the harvest for that vegetable was over 1 pound. Otherwise, it returns false. Notice we can use the first variable we computed in the definition of the second. So again, we take the garden harvest data and then we add 2 new variables, weight pounds and over 1 pound. Filter deletes some of the cases by specifying we've moved on to the case changing verbs. Filter deletes some of the cases by specifying which cases to keep. The table shows some of the operators that are used in filtering. You can see more in the cheat sheet or the document that goes with this video. Separating arguments in a filter by a comma is the same as using and. So each of the filters will be applied. In the code here, we start with the garden harvest data and then filter to the tomatoes and cucumbers, where the harvest date was on or after August 10th. That is greater than or equal to August 10th. Continuing with the case-changing verbs, arrange reorders the cases according to a specified criteria. To sort in reverse order based on the variable x, we can use arrange and this descend function in there. We can also arrange by the data by multiple variables. It will arrange by the first one first, then arranges by the next variable within the already arranged first variable, and so on. We see an example of this in the code here. We start with the garden harvest data, and then arrange cases in alphabetical order by vegetable. Then within each vegetable, the cases are arranged in descending order of weight. So I can see for each vegetable, the heaviest to the lightest harvests. Moving on to variable and case-changing verbs. Summarize takes an entire data frame as input and outputs a single row with one or more summary statistics. Like mutate, we can have more than one new variable by separating them by commas and giving them names to the left of the equal sign. In this code, we take the garden harvest data and then compute obs, which is how many observations there are, average weight, and standard deviation of weight. Group by groups the cases of a data frame by a specified set of variables. When using group by alone, the size of the stored data frame does not actually change. Neither the cases nor the variables change. Most commonly, this function is used before a summarize to create grouped summaries. We'll see that in just a moment. In this code, the data doesn't appear any different, right? This looks the same as the garden harvest data. If you run that code in the console, you would see the output that's shown right here below the table. This means that the data are grouped by date and that there are 66 groups or dates in this case. In this code, we see an example of a grouped summary. So here we've used the summarize after the group by. The code starts with the garden harvest data, and then it groups it by date. Then for each date, the weights are summed. So we have the total harvest in grams on each date. Using the pipe, it is easy to connect pieces of code together and even to pipe into a ggplot. In this code, we do the following. Start with the garden harvest data, and then select vegetable, date, and weight, and then add weight in pounds variable, this weight pounds, and then filter to tomato and pea vegetables, and then group by vegetable and date, and then summarize the data. I lost my train of thought. Summarize to compute the daily weight in pounds. And then we're going to add another variable which computes the cumulative weight by date. So it keeps adding more weight for each date. And then we get ready to plot it with the ggplot function by putting the date on the x-axis and cumulative weight on the y-axis and coloring by vegetable. and we add our GM layer and plot a line. You can do many cool things already with these couple dozen plotting and wrangling functions I've shown you. How exciting, right? One more thing before we finish. As we're piping code together, it's important to remember that this doesn't change your original data. This is a very common mistake. If I look at garden harvest after doing, so here I've done all this piped code, and now I ask it to print out garden harvest, notice that this looks and still is my original garden harvest data. This is not this wrangled data. If we want to save this wrangled data and access it in more than once or in a later step, then we can save that data set. So here I've saved it as daily summary tomato P. And then I can access that data set later by calling that new data set name. Okay, that's all for now.